Hello, my name is Robert Siofe. Welcome to the presentation of T7010T course. It's a polymer science and engineering course, in particular processing and design part, and it's a 7.5 credits course. I'm going to tell you about the logistics of the course and about what is expected from you in order for course to be successful, and that you can pass it with a reasonably good grade. Uh, it's basically lecture 0 really. We are discussing general questions here. There is no actual information about the polymers yet, just about how you are going to learn about these things. And yeah, like I said, my name is Robert Siof and I'm examiner for this course. I am actually giving this course on my own, but I'm also using lectures prepared by some of my colleagues, Nazani Nemami and Leonard Wallstrom. The course consists of 18 lectures which are in PowerPoint, but actually they are converted to PDF files and they are available from Frontier for you. And this is a web-based course, so actually those lectures are not going to be given in the classroom. These are the lectures you are going to read yourself, and based on those lectures you will also then complete assignments within the course. Additionally to lectures, of course, there is a compendium about which I will be telling you in a little while. Anyhow, when we look at the requirements of the course, what you have to do, there will be laboratory work, actually 2 of them, and homeworks, up to 4 homeworks, and of course exams. These assignments, as you can see, are marked in red font, and they are compulsory to pass the course. There's going to be a very short control test as well, and that's a control test for basically giving you opportunity to score some more points, but it's not mandatory. It's just to check your level of your knowledge at some point. It's going to happen maybe at around the middle of the course. As you can see on the right hand side of this slide, you can see points, and these are the points you can score for different assignments. And it's important that you do well, because all of these points then will be summed up and a grade will be given for a course. Literature for the course consists of those lectures which I already mentioned, and also compendium on the web, but of course you are very welcome and I encourage you to use web to find information, and of course library has very good resources, electronic resources, as well as printed books and papers and so on and so forth. Here we have a actually compendium I mentioned before. It's pretty much consists of lectures and chapters from books. You can see on the left hand side different topics within the course, and according to that also on the right hand side you can see lectures and chapters which correspond to those lectures. The idea is that it's a really web-based course, but it also means that it's very much self-study course. You have the lecture. Lecture gives you general information, but then you have to read a chapter in order to understand the lecture completely. Since it's not given in a classroom, you will not have my comments. Although we can arrange some meetings where you will have chance to ask questions. Those can be either physical meetings or virtual meetings on the web. But as it is, you look through the lecture, you read a chapter, and you should be able to fulfill assignments which are given in the course. Well, on the next slide we have here actually a list of those assignments. It's 4 homeworks, as I mentioned, and 2 labs. You can see here the homework 1 is about DSC curves or DSC method as such to characterize polymers. You will have to be able to look at the diagrams and make analysis, answer certain questions. Homework 2 is a comparison of polymers. You will be given 4 different polymers to work with. Polymers will be given by names and also chemical composition, of course, so you have to compare their properties based on that. Actually, this is where I would like to mention that the whole course is meant to connect molecular structure of polymers with their properties, and molecular structure of course will come or will depend very much on processing. So you have processing parameters, and then you have molecular structure, which depends on that, and then you have a mechanical or thermal properties, which depends on molecular structure. So we have this chain of events, so to speak, then we should be able to connect processing with the properties. When I say processing, different processing conditions such as, for example, temperature rate, heating rate, cooling rate, and such. As an example, I can mention that cooling rate will very much affect crystallinity of polymer, for instance. Anyway, and then you will be given also in this homework appendix with different curves and tables. So we will have properties of those polymers, and you should be able to looking at the properties, looking at the chemical composition or chemical formula rather, be able to discuss why some polymers have a better stiffness or higher stiffness than others, or why thermal properties are different, and so on and so forth. Homework 3 and homework 4, these are two homeworks which will be joined together in one. It's about manufacturing and material selection, and basic idea is that you are given different products and you will have to discuss what are the possible manufacturing methods for these products and what are the materials used currently and possible alternatives for those materials, and also talk about processing conditions, how they can be altered in order to alter product properties, and so on. Laboratory exercise 1 is the thermomechanical properties of polymers, and in this particular case we are going to work with a PET bottle. These are the bottles you usually buy your soft drinks in, and we will be looking into the questions about manufacturing of these products, of these bottles, and also looking at the bottles themselves, cutting them up in different directions, looking at the properties in different directions, and trying to explain those properties by linking it to molecular structure. Lab 2 is the fracture properties of polymers. It's exactly what it says. We will be measuring fracture toughness of the two different polymers, one very brittle, one quite ductile, and you will be able to compare them, compare behavior, compare things you see during a test, and so on and so forth. All of this, as you can see, assignments, it says report at the end of it, so you really have to write a report. Like, for example, in homework 1 there will be certain questions to answer, but it's not enough that you just write an answer. It has to be actually a smooth report with introduction, with discussion, with conclusions, exactly like a scientific paper, and it goes for all of the assignments, for the homeworks as well as for laboratory work exercises. And it's very important that you structure your report well, and that it's actually, as it's you can see it here at the bottom, the layout and structure of the report is as important as its content. So please take care of that and do the good job when you write your reports. Well, to sum up, really, what is needed to pass the course: you need exam, you need labs, and you need homeworks to be accepted by me, and basically your report's accepted. And exam, when you do exam, you have to score at least 50% of the maximum points you have in the questions, which will be usually 100. And of course, according to that, you can see in point 2 on this slide that everything is summed up together, and then you can get a grade depending on how much of points you have scored. And this is percentage of maximum points which are available. And you see it's 40, 55, 75. These are the thresholds for different grades. When it comes to exam is going to be graded similarly, but the thresholds are slightly different. It's 50, 65, and 80 points out of 100. By the way, this is exam, it's not a written exam. You are going to actually discuss with me questions on exam and answer questions during the physical meeting. By the way, since I touched upon physical meetings, there will be also physical meeting for the laboratory exercise. We do all labs at once in one day. It will take probably anywhere between 4 to 8 hours, but we will set up a special day for this, and we will do it during one day. It should be no problem. As for exam, the exam works like this. You come to me, I give you questions. I have various versions of questions, so everyone gets their own version. Then you have 1 hour to prepare, and then you come in my office and we discuss your answers. You will explain what you have understood and how things are working. And you can see here I put that everything has to be submitted in time, and that means that you will have deadlines for homeworks and lab reports. If you do it in time, you can actually score some bonus points for that. If you are not in time, you still have to pass, of course, but you might not get any points for your reports in that case. We are of course going to interact and communicate during the course, and that means that you can submit questions via Fronter, you can send me emails, we can have personal consultations, meaning we can have meetings, but then I would appreciate very much that you send me an email and we set up a time for that. And as I already mentioned, we will have at least 2 meetings during the course. That would be for the labs and for the exam. And of course, you will have dates for those events, and I will set up Doodle poll for that, so we can easily decide which is most appropriate time for all of us. But preliminary, I can say that the first week of March probably is going to be the lab week, and then end of March is going to be examination week, and then we can have also re-examination. I'm very flexible with these times, and I'm sure we can come to some common time when we can do it. That was all I would like to tell you for now. Of course, you are welcome to ask additional questions. The last thing I would like just to wish you good luck, and I am sure we will do very good in this course.